Okay, let's continue static analysis. Okay, we currently on Varsto's website and to see what kind of variable information can be abstract from the P files. Okay, so we talk about signature, right? Signatures, right? Signatures right here, right? So basically, for this specific sample, its signature cannot be verified. Okay, there are two different scenario. First, it does not include any signature. Or second, it includes some signatures inside the PE file. However, those signatures cannot pass the verification function. Okay? For example, okay, we can see that there are 3 signers, okay, in this PE file. So we can click it and see, okay, the signer's name is called LEDIOOO. Okay, so its name is LEDIOOO. Okay, and then it has because you have a, if you want to do signature, you like to sign this PE file. Okay, you need to have a private key, right, at the first place. So someone, okay, some issuer, okay, you can see that issuer. Some issuer should keep your public key after you have your private key. So there are some date information, usage, something algorithm, and something like that. Okay. However, even if this P file contains 3 different signatures, okay, 3 different signatures. However, those signatures cannot be verified. Okay, either, for example, this signature is expired. As we can see, this signature only valid from 2018 to 2018 October. So we cannot verify it. This signature cannot be verified. Okay, because this signature is expired. Okay, or for example, right here, this signature is not expired, right? Because it's valid until 2028, and its status is valid, which means it is a valid signature. However, signature, you can imagine that a signature is a chain. Okay, so although 2 of the signature is valid, however, 1 of them is not valid, and then this signature chain is broken, so we cannot verify this signature. 中文的意思是说，签章这件事情实际上是一条链所以我们这边有3个签章嘛，可是你可以看到下面2个的 status 是 valid， 也就是说下面2个签名是没有问题的，可是第一个签名是有问题的，所以这个链就断掉了，就破了那在我们的认知里面，如果签名没有全部是 valid 的情况之下，这个签章就是错的，就是失效的，就是错的，所以我们就说这个没有办法过整个认证 verification 的流程，好吗？好 ，so basically sorry. Details. Okay, let's continue. Okay, after signature, that is, there are some PE file information. Okay, you have to remember that PE stands for portable executable. Okay, there are some information can be extracted from PE headers. For example, target machine. Okay, we have talked about machine last week, right? There's a specific field in the PE file, and there is a mapping table provided by Microsoft. Okay, so the numbers of this machine field, you can check it out in Microsoft's table. Okay, so it says it is a Intel 3A6 architecture. Okay, and it's compiled at 2018. Okay, its entry point, which means the offset of your code is 6,224 bytes. Okay, it has 4 sections. As we mentioned before, there can be a lot of different sections. Each sections contain different code or resources, for example, image or strings. Okay, when you compile your code into a P file, okay, your compiler will put different resources, strings, code, or a global variable, something like in different sections. So right here we have for this sample, it has 4 sections. So as we can see, there are 4 sections. Okay, there are 4 different names: dot text, dot rdata, dot data, dot rsc. Dot text means the code you write. Those for loops, those if else conditions, your statement, your assignment, your functions, all those things will be compiled into assembly and put into this section called text. So basically the size is 65536 bytes. Usually those are in bytes. Okay. And for this section, it's MD5. Okay, so we put all the bytes in this section into, so we put all this byte in this section, in this text section, to MD5 hash function, and the output is a unique value 665 blah blah blah. Okay, and there are 3 other sections. Okay, usually data or our data are for example your strings, your variables, something like that. Our resources, usually those section includes some images or some strings, something like that. Okay, remember there is a value right here called entropy. We will talk about this specific column, okay, by using our code. Okay, and we can see that this PE file imports different DLL file. DLL stands for dynamic load library, which means those functions, those libraries are provided by Windows. So you don't have to implement those code. You simply just include those libraries and invoke those libraries. For example, this malware sample, it used several functions. For example, get this arrow, hit free, locate real, allocation, LC map string, W stands for wide. Okay, set handle count, some function which maybe you don't know, but those hackers, they use this library, those functions provided by kernel32.dll file. Okay, and of course there are some other functions from other libraries. Okay, something like that. So you have to think about one thing. As a normal programmer, as when you deploy your benign software, what kind of Windows function you will use? Are they totally different from hackers' program? You have to think about this question. If you believe the function you use and the functions used by the attacker, they are different, and then you can use these functions as your features to create your classifier. 好，从我再讲一遍哈。所以我们走到这边的时候，你要思考一个问题，就是说我们现在如果要辨别好人写的程式跟坏人写的程式，那你可以想一想，好人就是你啊，你写的程式，你使用的这些 functions 跟 libraries， 会跟坏人使用的 functions 跟 libraries 会不一样吗？如果你觉得你用的 function 跟坏人用的 function 会不一样的话，那么你应该就把这件事情好好的描述下来，把它当做一个 feature 来用。然后呢，在你的 classifier 里面去考虑这个 feature， 对吗？ 那去考虑这个 feature 的时候，你的 classifier 就可以，你的 model 可能就会根据这个项目我们说你有很多 feature， 你可以有 S1、X2、SM 嘛，对不对？那你可以有某个 feature， 就是说，哎呀，你的程式有没有使用到 isChild 的这个function比如说这里没有使。如果你觉得大部分的坏人有用，可是你没有用，一般的好人都没有用，那这个 feature 就很有价值，你就应该当做其中一个 X、K、X 之类的。然后你去 build 你的 classifier 的时候，你就可以用这个维度把好人坏人分开来So you have to consider, okay, is those functions, okay, used by malicious software. Is indeed they are so unique, so normal users will not use such kind of functions. If you do think so, then you should put this information in your classifier. Okay. So further, there are some other information right here. Okay, so I just simply there are too many things. Okay. So I think that is enough for us. Okay, so next relations. Okay. So basically, if there's malicious software, they would like to contact remote server, for example, HTTP server, HTTPS server, okay? At least they have to include those URL, 就是 website URL in their P file, right? 就是说你要让这个坏的程式去连到remote 的 server， 比如说 HTTP server， 你起码要把那 HTTP server 的网址留在这个 P file 里面吧。所以你的 P file 里面去扫一扫，一定会有一些字串是跟网址长得很像的，对不对 ？So there are some URLs, right? Contact URLs. Okay, so you can see there are a lot of URLs. Okay, so maybe you can extract them from your P files by using static analysis, or you can set up a sandbox to do dynamic analysis and to capture all the HTTP traffic sent from the malicious file to the remote server, and you record all these URLs. OK， 你有两种方法第一种就是去 P 档里面去字串里面去挖有没有 URL， 对不对？另外就是你 set up 那个 sandbox， 找 dynamic analysis 的路线，去找一个 monitor 去观测它的网络流量，看有没有连到哪些 HTTP 的这个 server， 你就把那个 URL 留下来，都可以，就是这两种手段都可以让你得到这个 URL 这边的 URL。OK。And also, there are some contested domains, contested IP address, okay? And you can simply just use static analysis to extract them from your P file, or you can observe them from by using dynamic analysis. Okay? So that's it. Behavior, okay? If you do dynamic analysis, okay, those network communication can be observed by your monitors. Okay, those are HTTP requests, DNS resolutions, and I believe you have learned it in your network class. Okay, then file system action. When we do dynamic analysis, we can observe what files has been touched by the malware. So here's the list. Okay, we can see that this list open a lot of Windows system file. For example, WinIME32, that is for IME 就是那个输入法。Okay, IME is the imputation method. Okay, and so on and so forth. There are a lot of files has been touched by this malicious software. And as you can see that here, there is a very strange file has been created or touched or opened by this malicious file, which is under drive C, okay, document and setting administrator local setting temp, and there is a file called 996e.exe, okay, and we strongly believe that this file is a replication of itself, and the malicious file put this replication in this specific temporary directory. 我们很有理由相信这个档案呢，这个991.61.1通常我们用猜的就猜出来，它是这个恶意程式的自身的一个复制档。因为有时候他想要把自己藏在一些莫名其妙的地方，你放在桌面上不可行嘛，你身为一个 user， 你很常就会看到它，所以他通常会找一些他可以 access 的目录，因为你看这是一个 temp 的目录 ，temp 的目录大部分的人都可以 access， 因为它是暂存目录嘛，他会把自己换一个名字叫9961，然后把它塞在这个暂存目录里面，以后要再发作啊，或是要再复制啊，可能就很靠这个。那其他的东西呢？其他 DLL 就不一定了有些是拿过来用有些是偷偷篡改那个 DLL 都有可能啊。看他做一些非常 malicious 的事情，他什么事情都做And this one, sorry. And this one, okay, is very strange one. C driver C, okay, auto exet.bat. This file will be executed every time when you reboot your Windows system. OK， 中文就是说，这个档案很特殊就是说写在这个档案里面的指令呢，会每一次在你重开机的时候都被执行过一次，所以非常有可能就是说这个档案里面写的刚刚那个 temp 里面的那个档案，也就是说你每一次重开机的时候，因为 auto exec.bat 都会被系统执行过一遍。所以里面它就指向刚刚那个 temp 的那个档案嘛，所以那个藏在 temp 下面的档案就每一次开机就被执行一遍，所以你每一次重开机的时候，你的电脑就是在那个被感染的情况之下所以重开机也没有用，就是这个病毒还是一直会每一次被执行。OK， so in this way, every time when you reboot your computer, okay, the instruction, the command written in this BAT file will be executed, and most likely the file which in the temporary directory, okay, will be executed every time when you reboot. So every time when you reboot, your file is under infection. 就是你都是在被感染的情况之下。Registry actions. That means this P file, this malicious file, it tries to modify or try to access your configuration of your Windows system. 中文是说，这个档案呢，它会就是这个恶意程式，它会尝试的碰触或者是修改你 Windows 的设定值，因为 Windows Registry 就是放 Windows 设定值的地方。Okay, so there are a lot of registry, okay, configurations, settings, okay, will be modified or be accessed or be changed by this malicious, okay, files. Although we don't know why this malicious file would like to access such amount of Windows registry file. Okay, we don't know. However, okay, that is okay. It even create new registry or delete some registry. Okay, that's it. Okay, I think that is good enough. Okay, so let's go back to our code. Okay, so after we know there are a lot of variable information can be extracted from PE files. So how can we extract those files? There is a very useful Python package called PE file. So you can simply just install this package, okay, in your Colab, which is okay. So you simply just use this command to install PE file package in your Colab. So after that, you import this file. So that is the file we like to analyze, right? So very first thing is that you simply just call a very simple function, PE file dot capital PE. it will try to analyze the file you provided, which is pe32.exe, right? Fast load means we would like to do a complete analysis. Okay, so you can set it to false. So this object, okay, is analyzed PE file. So there are a lot of different functions can be called. For example, is this file a DLL file? No, it's not, because it is an EXE file. Is this file is a driver, which means is it Windows hardware driver or software driver? No, it is not. Or is it an EXE file? And yes, it is an EXE file. How does this package, PE file package? No, it is an EXE file. The code is exactly the same as I showed you last time. Okay, how do we know it is a PE file? We have to read the first 2 bits of this file to make sure it's a DOS file, and then there is a pointer pointing to another 4 byte. Okay, and this 4 byte should be written as capital P, capital E, 0 and 0, and then we know it is a PE file. So basically, you should follow the structure of PE file to make sure it is truly a PE file, not a file with .exe file extensions 啊，就是我们还是要就是这个EXE 这个啊，它的里面的 code 啊，你去看，它也是按照这个流程去知道说，你要先读前面几个 byte 是确定它是 DOS file， 然后找到 pointer， 然后 pointer 再找到那4个 byte， 那4 byte 里面一定要写 PE， 写线0，它才会确认它是 PE file， 然后它是 EXE file。你不能够说它的副档名是 EXE， 它就是 EXE 哦，这没有这回事哈。Okay, and of course there's some other information like what is the so that is an object, right? PEF is an object. So there are some attributes you can print them out. For example, file header dot machine. So 332. What is 332? So make sure you go back to the table. Okay, 332 is right here, right? So that is a 32-bit x86 architecture. Okay, 所以就查表了啊。So that is more convenient for you to print those value out. So you don't have to parse those files by yourself because PE file package has already done the things for you. So they simply just, for example, print file header timestamp, and that is the time that this file has been compiled. Okay, so there's another hash function, so we can get the hash function. Of course, you can print its MD5 value, SHA-1 value, SHA-256 value. Okay, so and then the next one is section. As we mentioned before, there are different sections which include different information in the section. So I'm afraid you have to take a look at this code by yourself. Okay, so that means I would like to print. There are 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 sections included in this PE file, and I can use the above code, okay, to print these files. And the name of this section is written here. Okay, it's very similar to the example which I show you in the ViceTotal, right? The name is .text, which include all the assembly code, machine code, okay, of this sample. TST 这个 section 里面放就是你 compile 完那些 code 了哈，就这样子。然后一样嘛哈 ，R data， 那RS RC reload 这些都是常见的名字啊。Of course, there are some very specific section. Okay, 00 config, GFIDS. Okay, for every different compilers, they have some their own rules. to name this section. So basically, you can name section using any strings. Okay, so basically there are 7 sections. Okay, and of course, here are some information right here, right? Those information are exactly the same as I show you in the virus total, okay? Including how many bytes in this section. For example, this one is 577024 bytes in this section, okay? So that is how many bytes. And that is entropy, which I will describe later. And that is the hash value of this section. So basically, you can use PE function, PE package to parse the PE file and output those things. And this can be variable when you do your model. Okay, so that is. So I will talk about entropy later, right? Entropy versus entropy. Okay, entropy later. So keep it in mind. Okay, the next thing I would like to mention is packing. Okay, packing. Okay, malware sometimes pack itself with some packing tools, okay? Because it can change its appearance for not being detected by antivirus engine. Okay, what is that package means? If you have a file, okay, and you compress it by using zip, and you can get another file, which is appearance. Appearance means every byte. It's totally different from the original one. But if you know how to uncompress, which means how to unzip this file, you can obtain the original file, right? 好，等我再讲一遍。如果你有个档案哈，然后呢，它有一个原本的样子嘛，所谓的样子就是它每一个 byte 每一个 bit 的样子哈。那然后如果你去对它做压缩啊，你压缩完之后会得到另外一个档案嘛？你那另外一个档案里面的每一个 byte 是不是都跟原本 byte 不一样？对不对？因为它有一个演算法可以压缩嘛，对不对？可是你可以经由解压缩把它还原成原本的样子，也就是说，你可以经过一个程序，让原本 file 的样子变成完全的另外一个样子，那么你就成功的做了一次 packing。packing 有很多技巧，压缩、解压缩是其中一种，加密、解密是其中一种，还有各式各样不同的 packing 的技术。packing 的技术的重点是它要让原本的样貌，就是每个 byte 的样子变成另外一个样子。因为很多 antivirus 的引擎嘛，这边有写哈，很多 antivirus 的引擎，他们就是根据你的样子，也就是说的每个 bit 每个 byte 来做 malicious software 的 detection。所以一旦你的样貌变了，你压缩过一遍了，你加密过一遍了，你的 byte 的样貌就变了嘛，对不对？那变了它就侦测不出来，对吗 ？Okay, so there are a lot of different packing techniques. For example, you can do compressed, uncompressed, encryption, decryption, and so on and so forth. As long as the files after compression, after the encryption, the appearance, which means the byte, is totally different, then antivirus engine may not detect this malicious software. So a lot of malicious software will do packing before the hacker release its malicious file. 所以在很多时候，那个骇客在释出他的这个恶意程式的时候，到网络上的时候，他们都会做一次的 packing。那下一个版本再做另外一个 packing， 就是不断的做各种不同的 packing， 所以它每一次的样貌都会变。那这样防毒软体公司就很难去抓到一个固定的 pattern， 因为压缩、解压缩、加密、解密出来的东西都很乱嘛。Okay, so here's a famous packer called UPX. Okay, you can check it out in the website or Wikipedia. Okay, so let's take a look. Okay, so basically you can install UPX package in your Colab as well. So you can install it. Okay. After that, okay, first things, we make a copy from to our original PuTTY32 exe file. Okay, and then we packed the copied file. So basically, okay, it says, okay, we have a ultimate packer for executables. Okay, the current version is 3.94. Okay, we have an original file right here, and after pack it is right here. The compression ratio is right here. The original format is Windows PE files, and after that is pack. So we can do list. Again, we can see that that is the original one, right? And that is the packed one. And we can see that the file size is a little bit different. So let's see. If we all take a look at this packed file by using the PE package, and it says, okay, after pack, it is still a PE file. After pack, it is still a 32-bit x68 architecture execution file. But after pack, as we mentioned before, since the size is different, the packed bytes are different. So this MD5, yes, this MD5 hash value is 4C6B, right? Which is different from the original one. Okay, and if we use this packed file to do signature verification, and it says it has no signature, right? Because this file has been reorganized, has been packed. Okay. So how if I have a file, if I have a lot of malicious file, how do I know this file has been packed? So 就中文上来说，就是你知道兵来将挡，水来土掩嘛，对不对？所以坏人会知道每次 release 他的东西之前要先包过啊，因为包过的内容就会变嘛哈，反正他可以再解。那就好人这边来说，那我们就要知道一个档案过来之后给你分析的时候，它是有被 pack 过的，还是没有被 pack 过的？好，对。So there's another tool called this one. If you install PE files, there's another package called PE utilities, PEUTILS. Okay, and then you can download a reference file from somewhere. Okay, from somewhere. Okay, from somewhere. Okay, so you can use this reference file and feed them into your program. Okay, and it says that where it says, okay, you use PE utilities, and there's a signature database, and you include your file, reference file. Okay, and you can ask the PE utility if this file has been packed or not. And for this file, that is putty32.exe, right? And it says no, this file is not packed. However, for this file, putty32 pack file, and it says yes, this file has been packed, and maybe, okay, it is packed by UPX and by using some LZ, and it's an algorithm, okay, and it's made by some invented by some mathematicians or computer science researchers. So basically, you can download a reference file from the internet, and you can use PE utility, and you feed the reference file to PE utilities, and the PE utilities can help you to identify if the PE file is packed or not. So that section. So we can see that the original putty file has 7 sections, right? But after packing, okay, after packing, the UPX tool only contain 3 sections. Of course, those 3 sections include all the original 7 sections. right? Okay, so it has different, for example, file size, different entropy, and different hash values right here. 就是说，我们原本的档案不是 PE32嘛，PuTTY 32嘛，然后里面有7个 section， 对不对？然后那个 packing 其实就是很妙，它就是把原本的东西啊，想办法把它包装起来，然后产生一个新的 PE 格式。那 PE 格式里面只有3个 section 啊，那想办法把原本的7个 section 想办法，它有它自己的演算法哈，想办法把它包装啊，然后把它塞在那个3个 section 里面，可以吗？然后这是 pack 嘛，那 unpack 的时候，它会想办法再把这3个 section 里面东西挖出来，然后想办法再把它还原成原本我们那个 PE 档案里面的那个7个 section。以范例来说是这样。So that is section and packing, and usually malicious hacker and those hackers will do packing before they distribute their malicious software. Okay, so that is okay. So again, we'll talk about entropy later. Okay, so here is another section. It's called libraries. Okay, as we saw in the VirusTotal, right? We can output how many libraries has been used by this malicious software, right? So okay, you have to take a look at this code by yourself. Okay, so I print. Okay, this PuTTY32. They use several different libraries right here, and those libraries provide the following functions for PuTTY32 就是这边就会你反正看上面的 code 嘛，好，这个范例是我写的哈，那你就可以知道我下面会印出来，就是说这个 PuTTY32啊，它用了哪些 Windows 的libraries 就前面的上面的这个名字点第2档啊，那些 libraries 提供 PuTTY32哪一些的functions， 所以 PuTTY 就是用这些 functions 就好了哈。那同样的哈，你可以想一下，好人在写一般的，因为 PuTTY 是一个那个 就是那个 SSH 的程式嘛，对不对？所以它里面应该就是有些 SSH 的东西啊，网络交换讯息啊，或者是做那个视窗界面出来的那些东西哈，就是由下面这些 function 组成的。那你就要想这些 function 组成到底跟一般的坏人在写那个坏程式的时候，他们是不是也会用这些 functions 啊？你可以思考一下哈。So I have to think about it. That is PuTTY32, right? So PuTTY32 use those functions to create its application. Okay, it has a GUI. You can input a lot of command. You can SSH. You can telnet to other remote servers. So they use these functions to create such kind of program. But however, those malicious programs, hackers, they use such kind of functions or they do not. Okay, if they are different, normal users use these functions and hackers do not use these functions, then you can use these functions as features to create your classifier. Okay, so next is string analysis. Okay, I believe you know what is ASCII table, right? ASCII table, right? There are 256 different characters, okay, in ASCII table, but not all of them are printable, right here. 就是 ASCII table 里面有256个不同的 character 嘛，但是不是每个都可以在荧幕上印出来的 ，OK？ 只有下面这一些啊，我印出来的这些可以被印出来。Only those characters can be printed. Okay, it's right here. So, if we would like to analyze the strings contained in the PE files, then we can do this. That means I would like to print out the consecutive characters which are all printable. 中文再讲一遍，我想要创造一个function，这个function可以吃 PE file， 然后里面要印出什么呢 ？consecutive 就是连续的嘛 ，characters 连续的字元，而那些字元全部都是 printable 的。 啊，比如说我们要去连一个 URL 里面字一定就全部都是 printable 嘛，对不对？或是我要印个字串在我的视窗里面，或是我字窗上面有标题，或者是说我的 PuTTY 里面就有一些 configuration 的，起码 button 上要有字嘛，对不对？那些东西应该都是 printable 的，所以我们可以尝试把这个 P file 里面所有连续可列印的字元全部都印出来，好吗？好 ，So I write the function right here. So here I would like to print all of the consecutive printable characters. So that's right here. So as you can see, the first consecutive printable characters is this program cannot be run in DOS mode. This string exactly in the first field, the very first field in the DOS headers. OK， 就这一串字啊，就真的在那个 PE 档案里面那个 DOS field， 我们讲 DOS field 是最上面嘛，对，它里面就有这些字，所以你其实就是可以无脑的把它印出来啊，你不用分析，你就是把连续可列印的字元把它印出来就好了。And as we can see that .txe, .rdat, those texts are exactly the name of the sections. 就是刚好 section 的名字啊，它也是连续可列印的字元嘛，所以你就可以把它印出来。Okay, all of them are sections name. Okay, and of course, accidentally 就是很巧合的，因为我们讲嘛，后面的东西都基本上应该就是比较 binary 啊，一些图片啊，一些这个 compile 好的这个 machine code 啊，他们就是恰好也可能有连续的字元哈，在 compile 完之后刚好是可列印的，就会像下面这个样子。I mean accidentally, okay? Your compile code, the images contained in your P files, they accidentally has some few bytes which are printable, but actually they are binary values. But because we do not distinguish them, so they will be printed as follows. Okay, so you can print it. But if there's indeed some strings which is very important for the malicious software, for example, IP address, the URL to connect it to the remote server. For example, some ransomware will put the Bitcoin address. They are all printable characters, right? And then those information, those strings will be printed right here. 好，这些算是有可能有些资料是有用的啦，好，有些可能资料是没有用的，好，有些字串啊，那就看你怎么样，把它放到你的模型里面去。Next will be byte secrets. Okay, if I do not want to analyze the structure of P file, I would like to analyze the P file 1 byte by 1 byte. 就是如果我很懒惰，我不想要分析 P file 的结构啊，因为 P file 的结构太麻烦了，那么多栏位，然后每个栏位有不同的意思，对不对？那如果我真的想要一个 byte 去分析 P file， 可不可以呢？可以，你就一个 byte 拿出来。Okay, so I write the function right here. Okay, we observe, we count the P file 1 byte by 1 byte. However, okay, 1 byte. Okay, as we know, 1 byte equals to a bit, right? Then a bit, okay, is from 0 to 255 if you view it as an integer. So we can count how many bytes in these P files belongs to 0 or belongs to 255. 就是说，我们把 P file 啊，我不想分析了，懒惰嘛，我就一个把它打开。那一个打开之后，我就一个 byte 一个 byte 数。那一个 byte 就8 bit 嘛，8 bit 不就是0到25嘛？所以我们就去数啊，这个 byte 啊，如果算出来的整数字刚好是100，我就在100里面加1，我就一个个数，我就数这个0跟255这256个不同的值啊，一个个 byte 到底在这个 P file 里面占的 distribution 长什么样子，就画下面的图。So we can draw the distribution, the byte distribution by using this function. 就是我们可以画，对不对 ？And as you can see that 0 0, okay, 0 0， 因为它是16进位嘛，所以是2位哈。0 0 has occupied has a lot of count within this PE file。就这个 PE file 里面的结构啊，如果你不论结构的话，你就单独的数，你会发现00哈，这个 byte 出现数量特别多。还有这个 ，this one is FF。These two value, okay, is the majority 就是多数了哈 of when you count the PE file in this way。那为什么00很多？因为 PE file 它有一定的结构嘛，对不对？所以然后它有一定的长度，所以有很多时候那个长度不到的时候，它填那个0进去，就是塞满那个结构不够的部分。或者有些数字嘛，比如说你有个整数，好了，你的整数是。那我们知道写 Java 或者写 C 啊，写 Python， 它们整数大概都32位元或64位元。可是有时候整数我们写里面的只是1嘛，那前面不就是0000一个31个0，然后再接一个1吗？对不对？就是很多数字啊，或者填充的 padding 的东西啊，里面都带很多的0，所以这个 PE 档里面就很多的0，好吗？Because PE file is structured, so sometimes we have to pad a lot of zeros or FF, which means all ones, to padding, okay, to do the padding of the PE file. So 00 and FF are extremely large, okay. However, if we take a look at pack file, and we can see that after packing this file, okay, the distribution, the byte distribution of the packet file is quite even, right? The release part. Of course, 00 and FF still are the majority. However, all the other bytes from 1 to 254, they are quite even. Unlike a normal PE file, they are not that even. 就是在我们发现在 pack 过程，因为你知道我们刚刚不是讲吗 ？pack 会应用的技术有哪一些啊？不外乎就是什么加解密啦，还有这个加压缩解压缩嘛。那你知道压缩解压缩跟加解密啊，他们都数学家发明的嘛，对不对？就把原本的 byte 想办法做一些运算，变成另外的 byte。压缩、解压缩还有加密、解密，它们都有一个特性，就是它们会尽量没有办法让东西在应该说它会 evenly distribute 它的产出。你看嘛，一个字被加密过之后，它应该要均匀的散布在00这个 byte 到2到 FF 这个 byte 之间，这样才不会被人猜出来要怎么样解密。所以 hash 啊、加密啊、压缩啊，他们都有一些数学的理论，他们都会均匀的让原本的 byte 散布在新的 byte 上，所以就会产生这个效果。Compression, decompression, encryption, decryption, the mathematics behind them are hashes or some encryption algorithms. Those mechanisms will evenly distribute the original byte to another space, which is the below one, will evenly distribute their bytes, so that you cannot do decryption without key. You cannot do uncompressed without key, something like that. Okay, those are mathematical features. 就它们有一些这个数学的特性。So even if you do not have PE utility, you can simply just count the byte distribution of your PE file to know if this file is packed or not packed. 所以即使你没有我们刚刚讲那个 PE utility 那个工具啊，没有那个 reference file 啊，你可以单纯的就借由 count 这个 byte 的 distribution， 如果你看到它这么平均，它一定加密过，一定压缩过，一定 pack 过。如果你看到档案比较像上面那个样子，那就是一个一般的 PE 档，因为一般的 PE 档里面00很多 ，FF 很多，然后中间的东西，因为中间都是 code 嘛 ，code 的用字有一定的 distribution， 所以它会有一点不平均。好，它的用字有点不平均，好吗 ？So that the next one is assembly. So basically, because our code in the TEXT text section, they are compiled machine code, right? So basically, you can deassembly them. So follow this code, okay? Follow this code, and we have several package can help us to decompile, which means deassembly those code. 好，所以这边就是说我们可以，因为里面有很多 machine code 嘛，所以我们可以对它做 deassembly， 就是把它还原成 assembly 的样子，就把它印出来。OK， some researchers believe that the assembly code like this, okay, we can tell the difference between a malicious assembly and a benign assembly. Some researchers believe that. So maybe that is a very useful information for you to do some research about assembly code and to distinguish malicious assembly and benign assembly. 我觉得有些研究者认为说，你把那些 code 做完这个 deassembly 之后呢，你有些人可以看得出来，但我们可能比较不行的哈，因为我们这个经验比较少。有些人可以看出来，他这样写就是坏人的写法啊，另外那样写就是好人的写法啊。如果你真的可以辨认出来这件事情的话，那你就应该把 deassembly 之后的结果放到你的 model 里面去，作为其中一个 feature， 然后去做你 classify， 好吗？好，那我们来看一下 entropy 在哪里，是不是上面？还是不是在这个？好 ，entropy 在下一个哈，在下一个。Okay, let's take the last one. Okay, sometimes we have another hash called fuzzy hash. So you can simply just input your PE file into such kind of hash. This hash has a very specific feature, which is if your input byte is similar, then after you input those files into fuzzy hash, the hash result will be similar as well if your input bytes are similar. So you can try this function as well. Okay, that is the last one. Okay, fuzzy hash 的意思就是说，我们的 hash 都是说你要产出一个独特的 hash 值嘛，对不对？但是 fuzzy hash 不是哦。fuzzy hash 是如果你的 code、你的 byte 原本是相近的，你有两个档案，它们里面的内容 assembly 啊 P 的内容是相近的，那它丢进去 fuzzy hash 之后，它出来的 hash 值也会是相近的，所以我们就可以用这个方式来测量两个档案有多相似，可以吗？那详细的我们就不讲，因为这个比较少用啊。那也就是说，如果有一个骇客，他今天写了一支坏程式，然后做好打包丢到外面去，那他明天呢想了想，有个地方可以修改一下，所以他就修改了他的 code， 再重新 compile， 再重新打包，再重新丢出去。那现在有两支嘛，对不对？可是两支都是来源都是差不多的，对不对？所以你要做的事情就是 unpack， 那你就得到两个 unpack 的东西，然后你把这两个东西拿去做相似度的比较。那当然相似度比较有很多种，我们以后还会讲很多不同种。那其中一种是这个 fuzzy hash。如果你发现它的 fuzzy hash 也很相似，那就表示这两个 unpack 过的 PE 档案，它原生也很相似，所以我们就几乎能够判定说，这两个 unpack 的档案应该是来自于同一个骇客的手笔，因为他们两个的差异很少，所以这两个应该就是比如说，兄弟姐妹的关系啊，或是同家族的啊，或是同一个骇客输出的啊，或者说他们做相似的功能动作啊，这些东西就给大家做参考。那 static analysis 能够做的事情就大概就是这一些 ，OK，so that is the technique that we can apply to do static analysis, including to parse SP file headers to extract the useful information from those headers. Second, to understand what are the sections used by these P files. Third, what libraries that invoked by those P files. Fourth, what strings are contained in these P files. Next, what is the byte distribution of these P files? Something like that. So those are very useful information for us. So we will use this information as an example to do a classifying. Okay, so let's stop right here. So it's 10 after 11. So let's come back at 11:20. Okay.